So the title to this complex applied mathematics is Phase Response Near Fold of Limit Cycle Bifurcation. And I'm just going to give you an idea of why this project is interesting. So we deal with phase response curves. If you have a neuron which is spiking more or less regularly, you can assign a phase to it. And this phase can, like by convention, increase linearly from one spike to the next. So now if you apply a small perturbation to this neuron, so you give it a little current impulse, this can affect the timing of the next spike. So as you can see in red, this is the perturbed neuron, and the spike comes a little bit earlier. And as we have this linear relationship between phase and time, we can assign a little phase difference to this. So now if you do an experiment and you perturb the neuron at different time steps during this cycle, you get a phase response curve, which basically tells you that depending on where you perturb the neuron, how you will affect the second spike. And those phase response curves are interesting because they determine the filter properties of the neuron. They are important for the synchronization and network behavior following from this. Our project is to find or to determine this phase response curve near a certain bifurcation, which is the fold of limit cycles bifurcation. We do this by using nonlinear and nonlinear dynamical models, the persistent sodium and potassium model from Wichert and the Wang-Bojaki model, if someone cares. And nice. Cool. So the fold of limit cycle bifurcation is interesting because in type 2 neurons, it is where the spiking can start. It is, for those who like bifurcations and those things, where a stable and an unstable limit cycle appears simultaneously. As you can see here, the unstable limit cycle crashes into the resting point. And so we tried to find this PRC with numerical continuation. There's a software for it, which is called Auto. It's in Fortran. And if you want to see our PRCs and learn more about why they're cool, come to poster 42. And now enjoy your dinner.